In this video, we're going to look at epidemiological studies. How do you carry them out? Why do we do it? And what makes a good one? So let's have a look at some terminology. First of all, epidemiology. We've got to understand that epidemiology is the study of patterns of the causes of disorders and diseases in defined populations. So by patterns, we could include things like incidence or prevalence. So words we've met before. So incidence is the number of new cases, and the prevalence is the number of cases in a population in total. So an epidemiological study is something that is systematic. It's ongoing, and it's where we collect statistical analysis, or we interpret large quantities of data, and again we're looking about the patterns and the causes of disorders and diseases in defined populations. So let's have a look at the different types of diseases, and there's a lovely little flow diagram here showing how different types of epidemiological studies are related to each other. We're going to deal with each of these in turn. So first of all, the most straightforward type of epidemiological study is a descriptive study. So this is observational, and we are looking at who, what, where, and when. So we're describing who gets it, what do they get, where are they living, or what are they doing, and when do they get it. So this will be patterns grouped by categories. So you might notice that older people tend to be the ones who get cancer, and then you have the ability to form a hypothesis that you can then go on and test. So the next step after a descriptive study would be to do an analytical study, because this now collects the why and the how. So we're now looking, if it's analytical, we're looking at numerical data. So the actual number of deaths, the number of new cases, the incidence, or the number of people affected at any time, the prevalence. And there are two types of analytical study: case control studies and cohort studies. So case control studies are where you get at a point in time at the end, you look at two groups of people with the disease and people who are healthy. And then you look at what did they do in their life to lead them to end up being in the group they're in. So you have a look at all the people with the disease, and then you have a look at their medical history, and you compare that to a whole group of people who did not get the disease. This is what Doll did in the 1940s, Richard Doll. He looked at the number of people who ended up with lung cancer, and he studied what did they have in common, that people who did not have lung cancer, they did not have that in their lives. So the alternative type of analytical study is a cohort study, and this time we start at the beginning. Before anybody has got disease, we take two groups of people who are similar, and then we watch them for a long time. And then we come back at the end of this long time and see if people got the disease if they happen to get exposed to something. So this isn't the same as making them be exposed to it, but the example we've got here is a scientist who worked alongside Doll from the last slide, and that was a guy called Hill. And Hill noticed that if you took 40,000, a huge number, of doctors and looked at them over 10 years, the ones who were smoking were more likely to get lung cancer than the ones who did not. He didn't tell them to smoke, he just observed their habits to see what happened in the end. So that's an analytical study, which is a cohort study. So you take a big cohort and then have a look at the differences at the end. So then we would move on to an intervention study. So this is a type of experimental epidemiological study where you actually are testing the effectiveness of a treatment or testing the effectiveness of a public health campaign. So this time, if you do a truly experimental study, you would have a control group. So this is really helpful if we're looking at drug trials. So you would take a group, which is your test group with a new drug, and then you take your group, which is your control, which has a placebo. The word placebo means that it looks like the real thing, tastes like the real thing, but it actually does nothing, to see if psychology or something else is happening to perhaps change the outcome. So you do a proper controlled experiment. Now, sometimes that's not possible. So a quasi-experimental study is almost an experimental study. So you're doing something on purpose, you are intervening. So it's experimental, but it's not really a truly controlled experiment. And that's where things like perhaps vaccine trials come in. So with COVID, there were no control groups. Ethically, if you know this thing might work and you deliberately prevent a group of people from getting it, there are some ethical issues in that say, well, if you know it's going to be good, you ought to be giving it to everybody. So sometimes there are reasons why you have quasi-experimental studies. Similarly here with quit smoking, we would really want people to be quitting smoking. You wouldn't want to take a pregnant woman and say, don't quit smoking because I want you in my control group. That would be ethically unsound. So there are reasons why sometimes it's not possible to do a perfect scientific experiment. But we can collect data and then work out how efficient or effective a treatment or a public health campaign has been. So what are the features of a really good study? So this would be in your perfect scenario. You don't necessarily manage to get all of these all the time, but basically you want them to last for a long period of time with really large sample sizes, and we're talking thousands. You want to collect data from all sorts of people, affected, unaffected, different ages, sex, diet, occupation, lifestyle, exercise habits. You want to represent the widest bit of the population that you can that's appropriate. You would like to have a control group, and you would like to collect data on all sorts of things: incidence, prevalence, mortality, morbidity, and hopefully that would allow you to identify causes so that you can do something about it. Why bother? Well, we want to develop some kind of management plan with strategies to control or eliminate the disease, or maybe educate the public, and to do it in the most effective way possible. But of course, not everything is perfect. There are always limitations because we're involving people. You can get random errors where you get unpredictable variations. So this might affect the precision of your study. You can correct it using statistics and large sample sizes. That's the best way to get rid of random errors. They start to become less and less significant with the more and more people that are involved. But the biggest problem is usually bias, and that's a systematic error. So when you're talking about this in a response, you would not necessarily want to list all of these, but understand there are different types of bias. You could have bias of the people getting involved. So often, if you ask for volunteers, people who are interested in that disease will volunteer. So you could have volunteer bias. You could have sampling bias, so the person is looking for a particular result, so they go out looking for people who are likely to give them that result. Okay, so you can have misinformation bias, so people just can't remember. Did I smoke back then? I don't know. How many drinks did I have this week? They might not tell you the truth. You might lose some people because they die. So 10 years later, you go back to see if being healthy every week, going for a walk for 10 minutes every day, but they are no longer in your study because they died. So that makes it difficult to follow them up. You can have interviewer bias, just asking the kinds of questions that give them the answers they want to hear. But also you can have things out of your control, really out of your control, because something else is causing the disease and you hadn't considered it, and it gets into your data somehow. So you need to be prepared to think about some of the limitations, and try to manipulate your methodology so that you don't have them dominating your results. So, to sum up, we use epidemiological studies to look for patterns, and the reason we're looking for patterns is to try to bring about some kind of effective intervention later that allows us to manage the disease, treat it, eliminate it, and educate people to avoid it in future.